Mars, fine. With a velocity of 10 meters per second, this is it, right here. That's the 10. You don't have to do anything with this. It's right here. Its height in meters after t seconds is given by. So this is problem 12, and this should be h of t, not just h. 10t minus 1.86 t squared. Find the velocity of the rock after 1 second. So part A, v of 1. Part B, find the velocity of the rock when t is a. Okay. V of a. Perfect. When will the rock hit the surface? C, time for hitting surface. Okay. And the last one with velocity. Okay. Velocity for part C. Perfect. Okay. Good. So this is the distance formula or distance function. What does the velocity mean? By definition. Any definition. What does the velocity mean?
Distance something travels over a period of time.
Exactly. So the rate of change of distance with respect to, this is how lazy people write, with respect to time. Okay, good. What have we learned in this chapter about finding the rate of change of distance with respect to time if I have the distance function? How do I determine v of t?
Would you use the derivative?
Correct. Perfect. We do not know anything for now except the definition. The only definition that we have. So this is nothing else perfect than h prime of t. How do I determine this? And I only have one definition. How do I start?
(10t minus 1.86 t squared plus h, or f of x plus h over minus
I'm missing something extremely crucial. If I don't put that, it means nothing.
Limit as h.
Thank you. Very good. From it's uppercase h, of t plus h minus h of t divided by h. Awesome. These two together make this. Great job. Okay, now I have to write it again. I just wrote the definition. So limit as h approaches 0. So how do I write this? And this is the function.
(10t minus 1.86 t squared plus h.
We're talking about this for this function.
The 10 t plus h.
10t plus h in parentheses, very good, minus 1.86 times
t plus h squared in parentheses.
Excellent, well done. Careful now, minus changes the signs here, and don't want to write it again. That's how lazy people do work. They tried 2 steps in one. I'm sure you understood, so the minus in there. I just didn't want to write it again. So limit as h approaches 0. I will have to distribute here. Watch me run out of room again, run out of space in here. Minus 1.86. Can anyone give us this? Please make me proud, please.
T squared plus t plus 2th plus h squared.
Great job. Thank you very much. Minus 10t plus 1.86 t squared. I noticed something that makes me happy, at least for now. These two go away. Okay. I continue. I have no room here. The way I write. Limit as h approaches 0. 10h. I distribute carefully. Minus 1.86 t squared minus 2 and 1, 6, 7 and 1, 3. TH minus 1.86 h squared, and as expected, I ran out of room. There is no surprise there. Okay, what has to happen? All terms without h must go away. Yes, and they do. Goodbye. So now it has h, it has h, it has h. What is the next step?
Factor out the h.
Yes, thank you very much. When I was growing up, my grandmother was talking and talking and talking. Like I know it's annoying. I know I talk too much. My apologies, but this is the only way. If I repeat and repeat and repeat. I'm ready. Tell me what to write.
Um, 10 minus 3.72 t minus 1.86
Great job. Of course, as expected, these two go away. We're applying the limit. Please tell me what we get. When we say we apply the limit goes away. This operator is applied, done.
It would be 10.
Say it again.
10 minus 3.72 t.
Well done. 10 minus 3.72 t. This is h prime of t. This function will give us the slope or the rate of change of distance with respect to time at any point. How come any point? Yep. This is a quadratic, is differentiable everywhere. This exists everywhere. So fine. Now we determine v prime. So v of t, which is h prime of t. This is 10 minus 3.72 t. I like to write it in the correct order, in descending order. In part A, we're asked to find v of 1. No problem. V of 1 is 10 minus 3.72. So what do I get? Is it 6.28? Correct me if I'm wrong. I need the measurement unit. The measurement unit for any rate of change, we said it has a measurement unit for the top and the measurement unit for the bottom. Top being the distance, bottom being the time.
The time would be in seconds, right?
Yes. And I think you're right. I did not write the measurement unit. It said meters per second, yes. So it's meters per second. Any questions so far? Any questions so far? Good. So they want us to find V of A. Can anyone give us V of A? In other words, of anything we can think of.
Negative 3.72a plus 10.
Of course. Thank you very much. Time for hitting the surface. What does that mean? As you see, this is what happens. It reaches a maximum, is launched here, reaches a maximum, and then it hits the surface. So what do I need? What does this mean? When something hits the surface, it can be Mars or Earth, it doesn't matter. What do we know?
Velocity be 0.
the distance will be 0, right? When something hits the surface, the distance is 0. Good. So here's the distance. So I have 10t minus 1.86 t squared equals 0. What type of function, or I should say what type of equation is this?
Quadratic.
Thank you very much. How many solutions?
2.
Absolutely. Good. How will you address this? What will you do?
Realistically, the positive solution would be the realistic one because it has to go up first. If that makes sense. It can't hit the water before it's even been thrown.
So how will I start? I need to solve a quadratic equation. What is my starting point?
Factor out t.
Perfect. However, I want to arrange it in descending order and multiply by -1. So that's my preference. I will always do that. Present it in descending order and no negative leading coefficient. So I multiply both sides by -1 and in descending order. Perfect. I factor out t, 1.86t minus 10 equals 0, and I have to obtain two solutions. There's no negative solution here. So the first t equals how many seconds?
0.
Thank you very much. And the second t equals 10 over 1.6. 1.86 seconds. So obviously, when the time is 0, the object is on the surface. That's perfect. And at 10 divided by 1.86, and I don't know what that is. So time approximately 5.38 seconds. It hits the ground again. In part D, and last part here, we are asked to find the velocity for C. And here's the velocity function. So it starts as we were told already when t is 0, indeed, v of 0 is 10 meters per second, as we were told. And now I have to find v of 5.38, which will be negative 3.72 times 5.38 and plus 10, and let's see what that is. I have no idea. So negative 3.72 times 5.38 and plus 10. Okay, so this is negative 10.0136. It does not mean, so it's still meters per second. It only tells us the direction. So let me explain why that minus in front. You can say nobody can travel at negative speed. I completely agree. So this is age of t. And here's what happens. The velocity here means the rate of change, and this line has a slope of 10. Here, it's still positive, but a smaller slope. If this is 10, I'm going to say that this is 7. Here, and we're going to see this a lot, at the very top, at the peak, or turn, the velocity is 0. Why? Because this line is horizontal, and the slope of a horizontal line is 0. Now, because the function is, as you see, decreasing, here the function was increasing, the slope was positive. Here it was at the peak or valley. It's the same thing. The slope is 0. But now when the function starts decreasing, its slope becomes negative. It doesn't mean that v of 5.38 is a negative number. This negative indicates the direction of the vector. In other words, the distance decreases at this point, or when it hits the surface, by 10.0136 meters per second. Any questions? Good. Do we understand all steps in this problem?
I think I do.
Perfect.